All right, so we're going to talk about this key for our unit test tomorrow with quadratic properties. And so if you'll follow along with me, you guys can fast forward, rewind, pause, wherever you need to, but use this to help study for tonight's test. And just a reminder, one of the things that you guys will have access to is to be able to use that Desmos graphing calculator. And so be familiar with logging into Desmos. You can click that graphing calculator. I would have that pulled out anytime I'm doing any of my math work. So let's get this thing started. See how well we did. All right, I have a graph here. It says graph in vertex form. So for me, anytime I'm looking at vertex form, everything is going to be based off of the parent function, right? And so I know that parent function doesn't really fit, but I know that shape is up here. I see it should be reflected, so I know that shape goes down. So if we go out 2, down 4, out 2, down 4, and it's also going to move to the left 4 units. All right, so I'm starting to get to where I need to be, but not just left 4 units, but it's also going to go down. There we go. This is our final vertex. All right, final vertex, but not the final shape. So I'm erasing some of that information. All right, out 1, down 1, out 2, down 1, 2, 3, 4. I said this is still my parent function shape. The one thing that I have not addressed at this point yet is that number that's being multiplied out in front. Remember that is going to multiply each one of those y's. So instead of going up 1, it should go up 2. Instead of 4, it should be 8. It says 4, 5, 6, 7, 8. Every one of those y values should be doubled, which will make this final graph that I'm going to graph in red a little bit skinnier. All right, so let's move it on over to the next one. Now we don't have anything in front, which really helps us out, makes this easier to take that parent function. This shape should be the exact same. Opposite x to the left 2, down 2 should be my vertex. All right, so from here, out 1, up 1, out 2, up 4, out 1, up 1, out 2, up 1, 2, 3, 4. I'm sorry, I miscounted on that first one. There it is, should be my quadratic shape. All right, so describing the movement. And so from our parent function, again, I gave you guys that parent function. Inside the parentheses should be to the left 5. Right, outside the parentheses, change the color here, should be up 6. Identifying transformations. All right, now finding x-intercepts of a function. Now this is something that we're going to get more into detail when we talk about solving quadratics in the next unit. But ultimately, when it comes down to this unit, you have the access to technology. And let's type that into our Desmos calculator. So I'm going to pull up my calculator, minus 8x plus 12. So I have x squared minus 8x plus 12. Nope. I had my caps lock on, which wanted to change what was up. And so x squared minus 8x plus 12 should be graphed. Make sure I do have the right numbers. Minus 8x plus 12. Minus 8x plus 12. Awesome. So if I start looking at my zeros, my x-intercepts, I should have an x-intercept at 2, 0 and at 6, 0. I can click on those lines in the Desmos calculator and it will give me those points. So what are the x-intercepts? 2, 0, and 6, 0. All right, so which function, I'm sorry, not which, but is the function increasing or decreasing over the interval 0.5 to 1.5? So remember, those intervals, that's x values. So what I want to know is from 0.5, from this point right here to this point right here, is that graph increasing or decreasing? We always read graphs left to right, so it is increasing. So you get another transformation question, right? Inside the parentheses, horizontal translation, that is to the right 2. Outside the parentheses, down 7. And once you get another one in standard form, x-intercepts, help me remember 4x plus 3. Going to plug that in. It's a positive 4x plus 3. Let me make sure that is correct. Positive 4x plus 3. Positive 4x plus 3. All right, cool. So now I can see that I do have x-intercepts at -3 and -1. So -3, 0, and -1, 0. All right, so question that throws some people off that really is not as hard as you make it. The range of a function. Standard form. I know that function is going to open down. So my y's are going to be less than or equal to whatever that max value is. Now, if you want to find the axis of symmetry, so negative b, so negative -2 over 2a, 2, -2, so -1. It should be my axis of symmetry. I can plug that value in. And so 1 squared is 1. That's a -1 plus 2 minus 2. Should be 1 minus 2, which is -1. My range should be less than or equal to -1. I can check that out, right, and make sure I'm correct by plugging that in, once again, to my Desmos calculator. Let's look. It's a -x, 2x, -2x minus 2. Look what I got. -1, -1 should be my vertex. So all of my y's are less than that maximum. We are good there with range. And once again, range of a function. This time it's going to open up. Right? It's always going to open up because it's a positive in the front. So all of my y's are greater than or equal to whatever my max is. All right, so instead of trying to go through all the work, I can use that Desmos calculator. That is -8x plus 17. It's a positive out in front. And cool, let's make sure I have it typed in there correctly. -8x plus 17. All right, so my minimum value in that vertex, my minimum is 1. So all of my y's are greater than or equal to 1. Keep moving on. All right, key features in standard form. What is the vertex? And I am going to look at this mathematically. To find the axis of symmetry in standard form, -b over 2a. So -4 divided by 2 times 2 should be 4 over 4, which is 1. What's the axis of symmetry? Well, that's the line x equals 1. All All right, I'm going to use that value to find the vertex. And so I'm going to replace the x with the value of 1. 1 squared is 1. Negative 4 times 1 is negative 4. So 2 minus 4 minus 1, it should be what? Negative 2 minus 1 is negative 3. Right, should be the vertex of my function. Once again, you guys can check that, right, with the Desmos calculator. And so interpreting graphs again, what is the average rate of change of a function? Right, we talked about average rate of change, y2 minus y1 over x2 minus x1. I just got to find these 2 points. The x value. Right, so when x was 0.5, the y value was 20. When the x value is 1.5, the y value is 36. So to find the rate of change, I'm going to label this as 0.2. This is 0.1. So 20 minus 36 over 0.5 minus 1.5. And that should be negative 16 over negative 1. My average rate of change, or the slope of the line that connects those 2 points, should be positive 16. All right, again, some standard form key features. Let's find the axis of symmetry first. Negative b over 2 times a. Negative 4 over negative 2 should be a positive 2. I'm going to plug that value in. That axis of symmetry gets plugged in to find the y value. And so 2 squared is 4, so negative 4 plus 8 minus 5 should be what? 4 minus 5 is negative 1. Right, negative 4 plus 8 is 4. 4 minus 5 is negative 1. Cool, once again, check that with the Desmos graphing calculator. All right, going into the next slide. All right, let's look at this, just a situation first. The flight of 2 baseballs. Here's the graph A that represents the height of a baseball, right, in feet as a function of time, right, after it was hit by a player. Right, I know it's kind of hard to see, but if you notice that that graph doesn't actually cross the x-axis at the origin, right, it's a little higher than that. So how many zeros does this function have? Well, it will have 2 zeros, but in this situation, given this situation, right, in a real world situation, it only has 1 0. What is the estimated value? Well, that is going to cross the x-axis at 5 0. What does that 0 represent? We're talking about a baseball where it was hit, right? That 0 means the ball hit the ground in 5 seconds. Cool. Now, like I said, if we were looking at a function, know that that graph would come backwards, right? It would have a second 0, but that's not within my domain of our given situation. So that the function f of x be the function of the path of the soccer ball again, right? So Coach McKee states this. I stated that f of 2 is greater than f of 2.5. F of 2. When the function x has an x value of 2, is that greater So 232, is that a greater y value than 2.5? Is f of 2 greater than 2.5? Look at that, 32, last time I checked, was right. So that is what we need to explain. Hey, f of 2, is 32 greater than 20? Yep. All right, and behaviors. And don't make this more difficult. We know the quadratic is a U shape. Whereas the end behaviors of the function, here's what I know. That graph is going to open upside down. Each quadratic function has two ends. There's one, there's one. So as the x's increase, as you look on the right-hand side, this side, that graph will be decreasing. As x's decrease, so the left-hand side, this end, it will also be decreasing. You should have the same answers here. So once again, end behaviors, but this time look at the a value. A value is positive, so both should be opening up. So the same question, as x's increase, as you look on the right-hand side, that graph is also increasing. As the x's decrease, so as you look on the left-hand side, it is increasing. Average rate of change now from 1.5. And that should be 36, 2.5, 20. So what's the slope of those lines? 20 minus 36 over 2.5 minus 1.5. 20 minus 36 should give us a negative 16. Over 2.5 minus 1.5 should be 1. So that should be a negative 16 for our rate of change. Is the function increasing or decreasing over the interval 1.5? 1.5 to 3. To 3, remember that's the x values. So that function is going down from left to right. It is decreasing. And so again, this time Coach Rowland is looking at this function and he says that the f of x, the function where x is 5, and so what is that? 0.5, 20, is greater than when the x is 2. What do you think? Is that true? No. 20 is not greater than 32, so you should disagree. Right? So there's your key, there's your review. Hopefully that makes sense. Pause, rewind, go back as much as you need to.